When people think of UK tech, they think Cambridge. ARM processors powering billions of smartphones, billion-dollar exits, the obvious choice for deep tech founders. But what if I told you there's another city that's been quietly building world-changing technology for 2 centuries? A city where engineering students from the university invented chips that now control a third of the world's car engines. Where quantum physicists spun out a company that's protecting Britain's telecommunications infrastructure. Where a team developed haptic trainers that let you feel music through your feet. Bristol. Population 500,000, less than 6% the size of London, 120 miles west of the capital. This mid-sized English city might be the UK's best kept secret for deep tech founders. This is the story of how Bristol became a global technology powerhouse, and why the next wave of deep tech innovation might come from exactly where you least expect it. Bristol sits in southwest England, 90 minutes by train from London and Birmingham, close enough to matter, far enough to be affordable, and that affordability matters. Bristol office space and property is over 50% cheaper. For deep tech startups burning through cash on R&D, that's the difference between success and failure. But Bristol isn't just more affordable than London, it's a creative powerhouse. This is Banksy's home turf, the city where street art became a global movement. Where Massive Attack pioneered trip-hop and shaped electronic music for a generation, where Aardman Animations created Wallace and Gromit. There's something in the water here that makes people think differently, and it's young. With a median age of 33 years, Bristol has the lowest average age in the southwest and one of the youngest populations of any major UK city outside London. 2 world-class universities, University of Bristol and the University of the West of England, pump out 50,000 students every year. That's a constant pipeline of fresh technical talent. And then there's the quality of life, consistently rated in the UK's top 10 places to live. Green spaces, culture, a thriving music scene, the kind of place where engineers actually want to stay after graduation. Which brings us to something remarkable. 27,000 people work in tech roles in Bristol. That makes it the UK's second largest tech cluster after London. But Bristol's tech workers are doing something different. They're building hardware, they're working on quantum computers, they're designing chips, they're creating robots that can smell. Bristol has built a unique combination, the creative spirit that gave the world Banksy and Massive Attack, fused with 2 centuries of advanced engineering. Where else do you find that? It started with a man named Isambard Kingdom Brunel. In 1843, he launched the SS Great Britain from Bristol Harbour, the world's first iron-hulled, screw-propelled steamship. Not just a ship, a complete reimagining of what infrastructure could be. Brunel didn't just think about ships. He thought about systems. His Great Western Railway connected Bristol to London. But he went further. He envisioned seamless connection from London to New York, rail to Bristol, steamship across the Atlantic. One integrated network. That systems thinking, that's been in Bristol's DNA ever since. Fast forward to 1910, the Bristol Aeroplane Company is founded. Over the next 70 years, Bristol becomes synonymous with aerospace innovation. The Bristol Fighter, one of World War I's most successful aircraft. The Bristol Blenheim Bomber in World War II. The Britannia Turboprop in the 1950s. And then came Concorde. Bristol was the heart of British Concorde production. All British Concordes were assembled at Filton with the final production aircraft, Concorde 216 Alpha Foxtrot, completed there in 1978. The powerful Rolls-Royce Olympus engines that propelled Concorde were developed from Bristol Siddeley designs and built at Patchway, just minutes from Filton. Bristol designed and manufactured the critical engine bays, made from high-duty alloy, titanium and stainless steel to withstand the extreme heat of supersonic flight. When people think of Concorde, they think British-French collaboration between Bristol and Toulouse. The engineering heritage runs deep, so deep that when Concorde 216 made its final flight in November 2003, it returned home to Bristol, flying low over the Clifton Suspension Bridge before landing at Filton one last time. While Concorde was still flying, a different kind of revolution was happening. In 1978, the UK government made a £50 million bet on a Bristol semiconductor startup called Inmos. Initial funding came through the National Enterprise Board, approved by Prime Minister Jim Callaghan, despite significant political opposition. Inmos invented the transputer, a revolutionary parallel processing chip that changed computing architecture. The first transputer shipped in 1984, designed specifically for parallel computing at a time when the industry was focused on sequential processing. Over 1 billion products incorporating Inmos technology have been shipped. Derivatives of the transputer still power a third of digital TV set-top boxes worldwide. The company received £211 million total from the government before being sold to Thorn EMY in 1984 and later to ST Microelectronics. By the time Inmos was sold, the story should have ended, but the engineers stayed. They didn't move to Cambridge, they didn't move to London, they stayed in Bristol, and they built the next generation. Xemos was founded by former Inmos engineers, including David May, the transputer's lead architect. They now power premium audio devices around the world. GraphCore, tackling AI accelerators to challenge NVIDIA, was built on that same engineering foundation. PicoChip brought 4G technology. Blue Wireless is working on 5G infrastructure. American chip company International Rectifier noticed what was happening. They set up their automotive chip design center in Bristol. When German giant Infineon acquired them for $3 billion in 2015, they kept the Bristol operation because Bristol had become a semiconductor design hub with irreplaceable expertise. Today, a third of the world's car engines are controlled by chips designed in this city. But Bristol wasn't done innovating. In the 2000s, Bristol was building the infrastructure for the next technological era. In 1998, something significant happened quietly. Toshiba established its telecommunications research laboratory in Bristol, part of Toshiba Research Europe Limited, one of Toshiba's key overseas R&D operations. This wasn't a sales office. This was a corporate-level research lab focused on telecommunications, medical applications, and emerging quantum technologies. Why Bristol? The university's engineering expertise, the telecommunications heritage, and the kind of deep technical talent that doesn't move every 2 years chasing the next funding round. Fast forward to 2015. The Quantum Engineering Technology Labs are established at University of Bristol, one of only 4 UK quantum technology hubs. £235 million invested. They're working on quantum computing, quantum communications, quantum sensing. Toshiba's Bristol lab became deeply involved in quantum communications research, working alongside the university and other partners on securing the UK's future telecommunications infrastructure. In 2020, they deployed a 6-kilometre quantum key distribution network in Bristol itself, securing data transmission between the National Composites Centre and the Centre for Modelling and Simulation. And out of those university labs came KETS Quantum Security. Founded in 2016 by researchers who'd spent years working on quantum photonics, KETS developed chip-based quantum key distribution, a way to make communications unbreakable, even by future quantum computers. They've raised over £4 million and are now working with BT to secure the UK's telecommunications infrastructure against quantum threats. Dr. Chris Irvin, KETS CEO, describes it simply. Current cybersecurity is completely vulnerable to a quantum computer. We've developed a fully chip-based solution that provides security based on the laws of physics, not computational complexity. In 2021, Toshiba announced they'd developed the world's first chip-based quantum key distribution system, research that came directly from their Bristol and Cambridge operations working together. Then in 2024, Bristol deployed Isambard AI, the UK's most powerful supercomputer, 11th in the world, named after the same Brunel who connected Bristol to the world 200 years earlier. See the pattern? Ships, aerospace, semiconductors, AI, quantum. Bristol doesn't chase trends. It creates infrastructure for the next technological era, then builds on it for decades. And when global technology giants like Toshiba need to place their research labs, They don't just pick Cambridge or London, they choose Bristol too. What makes Bristol special isn't just the big success stories, it's the weird, wonderful companies tackling problems nobody else is solving. Take Groundwaves. Founded by Dr. Nick Inouye, they're putting haptic actuators into sneakers. You feel music through your feet, vibrations, synced to the bass, the rhythm, the beat. It sounds crazy until you realise they've developed what they claim is the world's leading haptic technology. Nick describes it as taking music to the next level, not just hearing it, but feeling it. Or Altered Carbon, not the Netflix show, but a Bristol company spinning out of the robotics lab. They've developed graphene sensors that give computers the ability to smell. Their K9 Sense technology can detect food going bad before you can smell it. It can sense wildfires before flames ignite. Founded in 2018, they've raised over £2 million and are working with the National Physical Laboratory to deploy sensors that could monitor vast landmasses for potential fires. Then there's Let Us Grow. While vertical farming startups were deploying hydroponics, Charlie Guy and his team from University of Bristol were rethinking everything. They developed an aeroponics system that suspends plant roots in air, feeding them with nutrient mist. The result? 70% faster growth rates than hydroponics, 95% less water than traditional agriculture. They've raised £2.35 million, built 2 state-of-the-art research centres, and just opened their Aeroponic Innovation Centre in 2024. Charlie's vision is simple. Climate change is threatening global food security. We're creating technology that can grow food anywhere, from cities to deserts, with minimal environmental impact. These companies share something. They're all solving hard problems that require years of R&D, deep technical expertise, and patient capital. The kind of problems that can't be solved with a pivot or a growth hack, the kind of problems Bristol has been solving for 200 years. So, how does a mid-sized city keep producing these companies? The answer is an ecosystem built specifically for deep tech. It starts with the universities. University of Bristol is a Russell Group research university, ranked 8th in the UK and consistently in the global top 60. £685 million in annual research income, 4 Nobel Prizes. But here's what matters. Bristol excels in exactly the disciplines that power deep tech. In the 2026 Complete University Guide, Bristol ranked 1st in the UK for engineering design, 3rd for aerospace engineering, 4th for mechanical engineering, and 6th for mathematics. Their research strength, quantum and particle physics, ranked 7th in the UK, materials science. Optical engineering, chemistry, ranked 7th in the UK with world-leading research in biochemistry and physical chemistry. Computer science, ranked 8th in the UK. In the Research Excellence Framework 2021, 94% of Bristol's research was rated as world-leading or internationally excellent. They're particularly strong in the exact areas deep tech needs: quantum technologies, advanced materials, AI and robotics. And then there's the University of the West of England. UWE brings strengths in robotics, big data and applied engineering, but their crown jewel is the Bristol Robotics Laboratory, a joint venture between UWE and University of Bristol. BRL is the UK's largest robotics research facility at over 4,600 square metres, home to 450 plus academics, researchers and industry practitioners. It's the most comprehensive academic centre for multidisciplinary robotics research in the UK. They're working on everything from human-robot interaction to agricultural robotics, medical robotics to autonomous systems. Together, these universities generate 13,000 academic papers annually. But here's what matters for founders. Bristol is the UK's #1 university for translating research into companies. And then there's Set Squared Bristol. Set Squared has been ranked the world's #1 university business incubator for 5 years running. Not UK, not Europe, the world. Since 2002, they've supported over 1,000 companies, created over £5 billion in economic value, achieved a 95% survival rate after 3 years, nearly double the UK average, raised £1.5 billion in investment. They understand that deep tech doesn't move at SAS speed. Notable alumni? GraphCore, $2.8 billion valuation. Orca Computing, quantum computing. Xylo, sold to Novo Nordisk for up to $800 million. Let us grow Kets, and dozens of others. But Set Squared isn't the only game in town. In 2015, Dr. Harry Destacroix was a PhD student at University of Bristol working on Xylo, developing a synthetic molecule that binds to glucose in blood. But he couldn't find lab space, so he did something unusual. He built his own incubator. Unit DX opened in 2017 in partnership with the University of Bristol. A year later, in 2018, Xylo was acquired by Novo Nordisk in a deal worth up to $800 million. One of the largest biotech exits in UK history. Most founders would take the money and retire. Destacroix doubled down on Bristol. He expanded Unit DX into Science Creates, a complete deep tech ecosystem. Today, Science Creates operates 45,000 square feet across 2 incubators in central Bristol, with a third facility, OMX, opening in 2026 that will add another 30,000 square feet. They provide specialised wet labs, clean rooms, and state-of-the-art equipment. They support around 100 companies that collectively raised £18.4 million in 2021 alone. But Science Creates isn't just lab space. In 2020, Destacroix launched Science Creates Ventures, a £15 million EIS fund that's since grown into SCVC, targeting $100 million. It's one of the rare UK venture funds built by exited founders, for founders. They specialise in exactly the kind of companies that seem crazy to conventional investors. Companies that need millions in R&D, don't know their final product yet, and will take 5 to 10 years to reach their potential. In 2025, Destacroix was awarded an MBE for services to science and the impact of the Science Creates ecosystem. And Bristol's deep tech companies, they're in Science Creates incubators, Imophoron developing next generation vaccines, Cytoseek creating cell therapies for cancer, Anaphyte working on graphene-based battery technology. Lucy Crump, who works with deep tech startups at Set Squared, explains the philosophy. We're not looking for the next food delivery app. We're looking for companies solving problems that will take 5 to 10 years, but will change entire industries when they do. There's also Engine Shed, 200 plus member companies. The Bristol and Bath Science Park, 160 acres, 70 plus companies, 4,000 plus jobs. The National Composites Centre, a £140 million facility working with aerospace, automotive and energy sectors. And the venture capital is following. Parkwalk Advisors managing £650 million. Breed Reply, Par Equity, and increasingly, London VCs looking for Bristol deals. Bristol has built something rare, an ecosystem specifically designed for companies that take patient capital, require deep technical expertise, and need 5 to 10 years to reach their potential. From Brunel's ships to Concorde to AI supercomputers, Bristol has been building the infrastructure of the future for 200 years. World's #1 university accelerator, a third of the world's car engines controlled by Bristol-designed chips, UK's most powerful supercomputer, UK's largest robotics lab, universities ranked first for engineering design and top 10 in quantum physics, chemistry and computer science, an $800 million biotech exit that launched an entire deep tech ecosystem, 50% cheaper than London, 50,000 students feeding the talent pipeline, Groundwaves letting you feel music through haptic sneakers, Altered Carbon giving computers the ability to smell, Kets protecting national infrastructure with quantum encryption, Let Us Grow reinventing how we grow food, Imophoron developing next generation vaccines. For founders, building in AI hardware, quantum tech, robotics, advanced materials, biotech or climate tech, this might be the UK's best kept secret. Cambridge has the brand, London has the capital, but Bristol has something different. 200 years of turning deep research into world-changing technology. The engineering, DNA, the patient capital, the technical talent, the creative spirit, the specialised infrastructure. and founders who've done it before, building the next generation. The question isn't whether Bristol can build the next wave of deep tech, it's whether you'll be part of it.